All right, I wanted to help explain how to find different types of coordinates with a point on the unit circle. So there's a few different ways that this could be asked. First way I'll talk about is if we want to find the exact coordinates and we're given an angle. So say our angle is 120 degrees. Okay. So to find the exact coordinates, we know the coordinates are talking about x and y. Right, on an x and y axes there. So we just want to figure out how far to the left or right do I have to go to plot this point at 120, how far up or down. And it's good to draw a picture. Remember, 0 is over here. 120 is kind of roughly there-ish. So we want to know how far would I have to go from the center, from this middle of the circle to get to that point. So to find the exact coordinates, all we're going to have to do is we know the x is dealing with cosine of the angle, and the y coordinate is for sine. So all we have to do in this case, if I want the exact coordinates and I'm given an angle, I will just say cosine of my angle would be the x, and sine of my angle would be the y. Okay, that's the exact coordinates if you're given an angle. Exact meaning it's not rounded. This is assuming whatever this number is worth, it's the entire thing and not rounded at all. Something else that we could be asked to find is approximate coordinates. And that's very similar. And let's assume I'm given the same angle of 120 degrees. So same thing, it's still going to be using the cosine of the angle and sine of the angle. This time, we're actually going to type it in the calculator. Grab my calculator here. Okay. Something also to consider as we move into more of the chapter with radians, you want to be in the right mode. So if you have like an 83 or 84, you can click the mode button and you want the degree to be highlighted, and if not, you can just arrow down and select it, but mine's already in degree mode. So the approximate coordinates, I'm just going to actually type in cosine of 120. That will be my x coordinate. So that's -0.5, and then I'll do sine of 120 for my y coordinate. So, and it depends what we're rounding to. I want to say it's 0.87. And again, it would probably be specified in the directions how many decimal places we need to round to. So that's the difference in the exact versus approximate when you're giving an angle. So the third thing that could happen here is, let me move my board, is I'm not given an angle. I want the exact coordinates, but I'm given a value within the circle. So again, let's assume that I'm over here. I don't know. We'll still keep the same kind of rough angle going on. So let's assume I'm not given the angle this time, but I'm given that the height or the sine of whatever the angle is about, or is 1/3. So that's this line right here if I were to go down to the flat level. So let's assume that that's 1/3. Okay, I want to find the coordinates. So this is not asking for to find the angle. If you did find the angle, you're probably going to get a rough estimate of what the angle is itself, and then when you plug that in, it's not going to be exact anymore. So I would be very hesitant to find the actual angle when you're given a side length of the triangle. All we're trying to do here is to find this coordinate, and we already know the y, or the vertical distance, is 1/3. So that's part of our coordinate there. We don't know this part, but we know this is going to be 1/3. Oops. Okay, so all we need to know is finding this x coordinate, or the other side, short side length of the triangle. And we can maybe call that x, or that's also referred to as cosine of the angle. Same thing. We do know the hypotenuse is always worth 1 in our unit circle, and this is assuming that's a right triangle. So we can use the Pythagorean theorem, or called the Pythagorean identity. It's the same idea. We're going to take one of our side lengths squared, plus the other side length. In this case, that's the one we don't know, but that would be our x coordinate of our coordinates here, equals our hypotenuse squared, which is just going to be a 1. So if I actually square these, and exact means that we don't want to have it in a decimal form, so we're going to keep these as fractions. So if I square this, I'll get 1/9 plus x squared equals 1. And I'm going to take away 1/9 from 1 whole. You can rewrite this as maybe 9/9 if you want to. So 9/9 minus 1/9 would be 8/9. And the last thing is I'll square root each side. Square root of 8 I can simplify to say 2 radical 2. Square root of 9 is worth 3. And in this scenario, if the only thing I'm given is the sine is worth 1/3, I'm going to assume this could either be the positive cosine, which would mean it's on the right side of the circle, or how my drawing is, which is not necessarily the actual question. If we're only given this part, it could be the positive or it could be on the left, which would have a negative sign. So that's the other coordinate for our coordinate. This is the x part of our coordinate. So I'd say it's plus or minus 2 radical 2 over 3, and then the y coordinate we had was 1/3. So there's kind of the different parts of basically what you're given and how it will help you find the coordinates.